Okay, basic graphs. So when you have a memory quiz on covering basic graphs, these are the graphs that I'm talking about. All right, and we'll talk more about memory quizzes. Okay, so y equal x looks as a line, slope 1. And I want to start getting you into the language of domain and range. So domain are all the x values that can be used, that's everything. And the range would be all the y values you can use, and that's everything. So y equal x squared parabola, even if it's just to x to the even integer, like x to the fourth, it's parabola-ish shaped. So domain is all reals, get to use everything. And the y's are include 0, bigger than or equal to 0. So you could say include, right? The square brackets include, and you never include the infinity. Y equal x cubed uses all reals for the x's and all reals for the y's. So it's odd integer, so it could be y equal x to the fifth also. Square root of x here starts at 0, so you could say 0 to infinity for domain and 0 to infinity for range. Then 1 over x, or 1 over x to an odd integer, could be like 1 over x cubed. The domain is all reals and don't use 0. And the range is all reals, don't use 0. So the range is the y values, and that would be for any of these. For 1 over x or 1 over x cubed. 1 over x squared is the hyperbola with both parts above the x-axis. And this could be 1 over x to the fourth, 1 over x to the sixth. It's going to look very similar. The domain is all reals, not 0. And the range are all the y values that are bigger than 0. So this x equal a is not a function. It's a vertical line here at a. So if we want to think in terms of domain, it would be x equal a, and the range would be all reals. So the y equal a is a horizontal line, and this is a function. So the only y value used is a, and the domain is all reals. So the absolute value of x, this is a good one to know. It's got a corner here, domain, all reals, and the range are y's bigger than or equal to 0. Then, moving on to x equal y squared. It's not a function, but the x values that are being used are from 0 to infinity, and the y values that are being used are negative infinity to infinity. X to the 1/3, this is the inverse of x cubed, so it's the sideways guy, and the domain and range are all reals. This is going to be an interesting graph we're going to look at a lot, x to the 2/3, and this little pinched in part is called a cusp. So the domain is all reals, the range is everything greater than equal to 0. So y equal e to the x, this is going to be an important one. Make sure you know this one. Goes up, it goes through this point, 0, 1. The domain is all reals, and the y's are bigger than 0. And then this is its inverse. So this point 0, 1 turns into this point 1, 0. The domain is x is bigger than 0, so that's a big deal. And the range is all y values are hit, because it just keeps going up. 10 to the x, so this is very similar to e to the x. E is the number 2.7-ish. And 10, same thing. So negative infinity to infinity for domain, and y is bigger than 0 for the range. Then log base 10, same thing. X has got to be bigger than 0. But there's actually an asymptote here. And the range is all reals, or negative infinity to infinity. So this is an equation of a circle. And so centered at the origin, not a function, right, because it does not pass that vertical line test. But the domain here would be all x's between a and negative a, and the y's between a and negative a. And if I take this and I try solving it for y, so first off, I would get a squared minus x squared. And if I take the square root, you remember when you take the square root, that you get the plus or minus. So if I was to take the positive, this gives me where the y's are positive, and where the y's are positive is above the x-axis, so it would be the top half of the circle. And if I take where the y is negative, that's, that would be here, where the y's are negative, so that's the bottom half of the circle. So get to know, be familiar with these two. All right, so you've probably never seen this, but these are going to be important. So whether it's written like this or written like this, it's going to give the same graph. So let's just go plug in some points. So if I plug in, well, we know we cannot use 0, right? Can't use 0, but let's just plug in 1. And I'm just going to plug it into this one. So I'd get 1 over 1, 1. Okay, let's plug in 2. Plugging it into here, so I'd get 2 over 2, and that's a 1. So I think we can kind of come to the conclusion that when I plug in positive numbers, I'm going to get 1, right? So 3 over 3, so I get 1. Okay, so now let's plug in a negative number. So again, plugging it into here. So I'd get the absolute value of negative 1, which would be 1 over negative 1. That gives me negative 1. Let's plug in negative 2. So I get 2 over negative 2. That's negative 1. I think we can establish that when I plug in negative numbers, I'm going to get negative 1. So let's see if we can get a picture here. So when I plug in positive numbers, I get 1. And when I plug in negative numbers, I get negative 1. And I can't use 0, so I'm going to put a hole there at 0. So this I'm going to call that graph because it's just going to come up often.